All right, we're going to do the second ANOVA example. So recall that we were trying to sell electronics in the store. We wanted to see which of the four locations in aisle front, kiosk, or expert performed the best with respect to sales. So we did a lot of work for this first example, this continent example. So let's try to make our lives as simple as possible. So instead of reproducing all of these tables by hand, how about we shortcut this? So this will be really helpful for your homework. So how about you go to ANOVA 1, our first example. Let's do move or copy. Create a copy. Make sure you're clicked on ANOVA 1 up here and click OK. Okay, so now I'm going to move this one over here. And then I'm just going to rename this tab to ANOVA 2. Okay, so these two tabs are the same right now, ANOVA 1 and ANOVA 2. But we want to update ANOVA 2 using our new data. So how about first I just update the wording of the problem. So how about I'm going to grab this, so copy over here. So let's update this. Okay. So here's our new problem. And now we want to update our data. So I'm going to go back over here, grab our data. So I'm going to do copy and then paste up here. And then I want to get rid of this data that's not actually a part of anything or a part of our data set. So I'm going to delete those. Okay. So if you look, this is already very close to done. Notice that these have all updated. Even look at our plot. So we need to change our title here to something like sales of electronics across store locations. And then here I might just say sales. Okay, and we already have a big part of this done. So when I click on the plot, so if you just click on the plot, it'll show the data that's highlighted. So because that earlier data set was longer than this one, how about if you just go down to this bottom right corner and you just drag that up? All right, it doesn't change anything, but now when you click on it, it's selecting only the proper amount of data. So right off the bat, we can see in aisle seems to be pretty different from the rest. We can see front seems to do the best, then kiosk, expert, then maybe in aisle. So we should expect maybe some differences, but at least between in aisle and front, that seems to definitely be a difference. But let's go ahead and update all of these tables. So first off, our groups have the incorrect name, so let's just rename these. So we have in aisle, front, kiosk, and expert. Sample size. So if you look, it's still kind of grabbing the wrong data set. So up here, instead of this going down to A11, I only want it to go down to A6. And I'm just going to do that for all of these, just have them go down to A6. So we're only selecting the proper amount of data. Okay. And this cell is fine, degrees of freedom. This is fine because these are all based on column K. So now we want to update our average. So I'm just going to change this to 6, change 11 to 6, change 11 to 6, and change 11 to 6. Okay. Here, also change this to 6. All right, and now we just do the same thing for variance. All we're doing is changing our dimensions so that we're selecting the proper data and not all of these empty cells. Okay, see, this is still 4, right? We still have 4 groups, so that doesn't change. Now we can look at our sum of squares. And everything should still be properly referenced. Check out. Right, when you click up in the formula, you can see all of these same cells are being referenced. So let's double check for within group. Yep. If I check in total. Yep. Degrees of freedom is 3, right? 4 minus 1. So this number didn't change, so that doesn't change. This is the difference between these two cells. Those don't change. And then this is just equal to n minus 1. All of these should basically be the same. So MSA would be SSA over degrees of freedom. MSW would be SSW over degrees of freedom. That's fine. F is MSA over MSW. That is fine. P-value. So again, we don't have to change anything here. All the formulas are already here. And because we have all of these as just formulas referencing other cells, all of these have been updated correctly. So there's actually nothing to do, and the ANOVA table is already done. And now, fortunately, because we have the same number of groups, this table is already very close to done. But first, we need to change our labels in our Tukey-Kramer table. So this is no longer Asia to Europe. This would be in aisle to front, and then in aisle to kiosk, in aisle to expert, front to kiosk, front to expert, kiosk to expert. Okay, if we just want to double check, if I just click on here, we can see that, okay, this is taking the difference between in aisle and front. I'll jump down here. I can see, okay, front to kiosk. Yes, it's taking the difference between the average of front and the average of kiosk. Down here, yes, I can see this is taking the difference between kiosk and expert. Okay, so this cell, this column is already done. Standard error. So we do need to change one thing. Recall that standard error does require us to take into account our sample size. So our sample size in that prior example, we had sample sizes of 10, but now we have sample sizes of 5. So what we want to do is update in this cell up here. So instead of dividing by 1 over 10, we want to divide by 1 over 5. So 1 over 5. And then I'll just drag this down. And then we need to change this studentized range value. So recall that it's C and N minus C degrees of freedom. So the 4 stays the same because we still have C groups, but our N is now 20. So instead of 36, this is now going to be 16. So now if we were to just go ahead and search, what was it, student range distribution calculator, studentized range distribution calculator, Tukey-Q. So we had 4 and 16. Calculate Q. So we want the 0.05, so I have 4.05. So now this is 4.05. And if you just give this a few more decimal places, you can see. All right, and this already has our results. So again, let's maybe take a step back. If we look at our ANOVA, we can see that our p-value is less than 0.05, and that our f-stat is bigger than our f-critical. So we reject the null hypothesis and say there is at least one difference in means between these 4 locations in the store. So now the question becomes which ones are different. So we do our Tukey-Kramer procedure, and we can see there's a difference between in aisle and front and in aisle to kiosk. So let's just see if that makes sense. So in aisle to front and an aisle to kiosk. Okay, that makes sense. Yeah, blue and red are not overlapping, and blue and green are not overlapping. But we did not see a difference between blue and purple, between an aisle and expert. Okay, and then front to kiosk and front to expert, those are also different. So let's just take a look. So front to kiosk, so red to green and red to purple. So that means front was different than all the other three groups. And aisle was only different to the red and the green. And then kiosk to expert, not different. So no difference between green and purple. Okay, so that's how we do it. That was obvious. I mean, to me, that felt a lot easier than our first time around. So I would just follow these steps where you create a copy of a completed ANOVA table, and then you can just copy paste the new data in, update just the cell references in this table, and then everything else should kind of update, and you can get your answer rather easily.